Hello, and welcome to this Ingram Micro webinar for AWS EC2. Myself and my colleague Mark will take you through some of the basics of EC2s, and hopefully by the end of this webinar, you'll have a good understanding of how you could use EC2s and be confident to move forward. Here is our agenda for the session. We've kept it quite broad, but hope to provide you a good overview. I'll take you through these topics, and then at the end, we'll run a demonstration of spinning up EC2s. Okay, so let's start. First question, what is EC2? Well, EC2 is the name AWS refers to its offering of virtual machines. An EC2, or more precisely an EC2 instance, is basically a server, just like you might be familiar with a server running in Hyper-V or VMware. An EC2 instance is a server built and running in the AWS cloud server environment. It's a virtual machine running on a physical server somewhere, just like you would build and run on other hypervisors or hyperscalers, whether that be on-premise, in your private cloud, or otherwise. Why the name? Well, AWS naming is simplistic, really, for the core services anyway. EC2 stands for Elastic Cloud Compute. And if you break that down, you have E and two Cs, thus EC2. It's quite logical, really, just like they've done the same with S3, simple storage solutions, S 3 times. So simple as that. EC2 is just a virtual server. But if they are just servers, what type of servers? Well, AWS offers a range of operating systems. Whilst AWS are often referenced in regards to Linux and open source servers, actually AWS has more Windows-based operating system servers running in its platform than Azure. And as you can see, you can even create an Apple Mac instance on AWS. So you have arguably the widest choice of operating systems available with AWS EC2. It's pretty easy to get started and spin up an EC2 instance, but let's cover off the basics of what you need before you're able to spin up an EC2. To start, of course, you will not be able to do anything without an AWS account. You can set one up easily, and there is zero commitment to what you have to use or length of time for the account. Equally, there are no limits to how much you can do. Once you set up your account, you have access to everything AWS offer. So regardless if you're starting from scratch or you're a large company, one account generally fits all. What's the catch? The only catch really is that you'd need to register with a form of payment, and that's generally a credit card. Whilst you can use the free tier and try things out with no or little cost, you need to provide a payment method. Simply put, no payment method equals no account. Once you've signed up, then you have access to everything via the AWS console. And as you see, you can get access to everything from the home dashboard. And to start using EC2, you simply click on the icon or search for it in the search bar at the top of the page. Before you get started, there are a few more things to consider. First, you need a network. You can't build a server without a network for it to attach to. Your server is going to need some connectivity, even if it's just for you to remote connect onto it. So you need to have a network in place. AWS provide default networks, which are created when you create your AWS account. These are perfectly okay to use if you just want to start using and testing an EC2. If you don't want to use default network, you can build up your own network configuration. You would select your own IP address range or CIDR block, then configure which region you want your network and EC2 to live in. You can build in any of the regions available. It may be you want to use a region that is closest to you or your client. Or of course, you can use the default US region, which is often the cheapest. AWS give you the freedom to build out a VPC, virtual private cloud, their network, that fits your requirements. The diagram here demonstrates what you would generally build out with public and private subnets and build across a couple of availability zones. But if this feels too much to start with, then just start with a default network and work up to configuring your own network. As solution architects, we would always advise that you spend time thinking about your network design up front before committing to anything long term, because there is plenty to consider. For example, AWS has 32 regions that you can utilize to build your resources in. With 102 availability zones and more coming online, this gives you the flexibility to run services local to your global teams or to satisfy compliance requirements. Using multiple availability zones gives your resources protection and resilience. All availability zones have fast connectivity, so you never have to worry about bandwidth or speed issues. Ultimately, you can build out a very resilient and fast network to meet your needs. Or for starters, you might just want a simple configuration and use the default one and build out. Now I have an account and we know the network we're going to use. So next we will need to think about what virtual machine we want to build. We looked at operating systems already, but there are decisions that go beyond just that. For example, what processor do you want to run on? What will the workload look like? Is it a high CPU application or just responding to an occasional web request? Is there a requirement for high IOPS on the disk drive? Do you need a dedicated machine? Does your machine need to be a bare metal machine that gives you full management and direct access to the hardware resources? Or can it simply be a shared instance? You'll also have the option to launch a pre-built templated EC2 instance that comes pre-packaged with services you might want. Or you might simply want to build up the OS from scratch and then load your applications and services. Even if you choose to build from scratch, you still need to understand certain options. When you go to launch an EC2 instance, you'll have to choose an instance type. When you watch the demo, you will see that actually choosing an instance is not as daunting as this slide might present. It's worth giving it some thought, though, up front about the type of usage and size of machine you might need. As this slide shows, you have options around machine workload on the top line and by processor down the side. This is a good guide to at least get you into a ballpark of the type of machine you will need. You then have to consider the size. With sizing, you can go big or small, depending on your choice of instance type. Each instance type has multiple options of size. Generally, you would start smaller, then right size as your workload increases. But if you have a mega app, then you might want to start big. This slide hopefully helps explain the instance type naming convention. So breaking it down from left to right. C is the instance family, 7 is the generation of the machine, and GN are the attributes. If we look at the instance types we saw before, we see the C7GN, and the G equals the Graviton processor type, and the N equals the enhanced network capabilities. And at the end, we have the X large, which of course represents the size of the machine. Next, we need to think about storage. You will need some form of storage to run your operating system on, so storage needs to be added when you launch your EC2 instance. Whilst you need a disk attached to your EC2 to build a machine, storage is actually separate to an EC2 and can be thought of and used independently. For example, if you need to move to other instances, recover from a failure or misconfiguration, or have to rebuild, having a disk storage component separate to your EC2 gives you lots of flexibility. Ultimately, to get started, you'll need to think about the size of the disk you want to build your operating system on to kick things off. And finally, in terms of getting started, you'll need to think about how you want to pay for your instance. The most common payment term is on demand. You pay for it when it's running. You don't pay for it when it's stopped. There are other options though. You can have spot instances. These offer great savings to the on-demand costs, but you have no security on the running operation of the server. If AWS needs the capacity for someone else, then they could turn your instance off and reuse your server resources for someone else. Spot instances are great for cost savings if you are just testing or evaluating. If, however, you want to commit to longer term savings, you could commit to reserved instances or savings plans. These give you greatly reduced costs for a longer term period commitment of usage. Okay, so we've covered off what you need to get started: an account, a network, and generally understanding of what EC2 configuration you want. So what's next? Well, I guess if you spin up an EC2, you'll also need to know how to configure and manage it. We start in the AWS console. Here you have the basic controls to start, stop, and terminate your EC2 instance. For clarity, when you start an instance, you start paying for it. And of course, you can only connect to it when it's running. When you stop an instance, you are not paying for it. And of course, you can't connect to it. Just a side note here, however, you do still pay for the disk storage if a machine is stopped. When you terminate the instance, it's deleted completely. You are not paying for it at that point, and in normal circumstances, the storage is also deleted as well. So these are the main three states of EC2 instance. There is a fourth, which is hibernate. This option is only available if selected as a feature when you launch the instance, and it has some special conditions. But in principle, you could use this function to pause the instance to save money without losing data and allowing you to spin up and boot up the machine more quickly again. So let's quickly touch on public and private IPs. A public IP is the IP address that's available across the internet from anywhere. Private IPs are those in your network VPC and are not publicly available. It's always good to consider if you need a public IP for your machine or if you can manage with just a private IP. Obviously, there are risks that come with exposing a machine with a public IP address. There are security functions in AWS to mitigate this, and of course, having a machine accessible by a public IP makes managing it much easier and less hoops to jump through when you're trying to connect to it. There are options, however, like Bastion Host or Jumpbox, so your machine is in a private network and you can access and can then only access via the Bastion host. It's worth noting that there are limits also to the number of public IPs that you can have, so you should be mindful of these limitations. And perhaps most importantly, be aware that if you stop and start an instance, any public IP address assigned to it will change. So when you want to manage your EC2, you need to be aware that potentially the IP address has changed. Coming back to storage, we mentioned before that a disk is separate to the EC2 instance. This gives you lots of flexibility to manage the disk and the storage independently of the instance. Most importantly is to consider if you need to retain the disk after termination of the machine, and/or if you just want to retain a copy via a snapshot. Snapshots are key to recovering a disk and can be easily used as a backup or recovery feature. Having a snapshot of your disk will protect you and even allow you to reuse the disk to spin up additional machines if needed. So make sure you have a snapshot of your disk when you're happy your EC2 is running correctly. Okay, so you have your EC2 machine running, but how do you connect to it? There are four options for connecting to EC2. First, there's RDP, generally used when running Windows machines. If you're using a public IP, you can connect directly via that, or you can use a Bastion host or Jumpbox. to then RDP onto that and then get access to your machine from there. Instance Connect was introduced this year by AWS. It removes the need for the public IPs or the Bastion host and allows you to configure a connection profile by using the AWS CLI commands. The configured profile allows you to RDP onto the server even if it has a private IP. This again is mainly for use with Windows machines. SSH is a very common protocol and often used in connection with managing Linux and open source servers. The Connect feature in AWS Console can be used if you've already configured the session manager in your account. This can be a little bit more complicated to get up and running, but longer term it adds a lot more convenience for connecting to your machines. So the question we started the session with was, what can we do with EC2? We now know we can build an EC2 with any operating system. We have a selection of processors we can use. We can scale a machine to be whatever size and capability we need it to be. And we have ways to manage and control it, including ways to reduce the spend. So the question is, what can we do? I would suggest the answer is you can do whatever you want. From building a simple web server to building a large-scale, graphic-intensive, CPU-hungry application server, you can build out anything you need. You can replicate or replace any of the servers you have on-premise or in your private cloud, or build out a specialized machine for any particular requirement you might have. Basically, if you can specify what you need, it's most likely there is a machine type that works just for you. But should you do it? Just because you can build out or replicate anything, should you? Well, whilst you can build up an EC2 to be whatever you want it to be, from a file server, a Microsoft Exchange server, a SQL database, or a monolith application server, it may not be the best usage or the most cost-effective. AWS have over 200 services, and many are designed and far more cost-effective and specific for intended use. There may be a better solution in the AWS range of services that suits your needs. But if you are early in your journey and you're comfortable with having a server to do the job, then you can use EC2. Test them out because there is no commitment and they are just the same as you would use with any other hypervisor. So I do encourage you to go and have a go and see what's possible. Hopefully that is giving you a decent understanding. And to demonstrate just how easy it is to spin up EC2s, my colleague will now walk through a demo. Over to you.